All right, let's get started. We are one of the last talks for today. Hopefully you guys have had a long but exciting day, and hopefully you have some energy left, because we're going to try and get you pumped up about writing Metro-style apps with HTML and Touch. I'm Reed Townsend. I'm a program manager in Windows. I work in the Human Interaction Platform team. I've been with Microsoft 11 years, mostly working on touch and pen support. In 2004, I joined Tablet and helped ship some of the very first touch support in Vista, which may be a surprise to some folks. I helped shepherd touch in Win 7 and again in Win 8. We're super excited about Win 8. I hope you guys are starting to get excited about it too. And we're really looking forward to seeing the apps you're going to build.
Hi, my name's Nick Wagner. I'm a program manager in the presentation and composition team. I joined Microsoft about 6 years ago as a developer working in the Windows deployment team. After that, I moved over to the security division, where I worked on building internet-scale web services. And then most recently, I'm really excited to be back in Windows, working on building great touch experiences. Now, hopefully, everybody's had a chance to play with their new tablets with touch. If you have, you'll notice that we've built Windows 8 from the ground up to be touch first. Now, you may have had a chance to attend a talk earlier today on designing Metro-style apps that are touch optimized. If you did, you'll know that they walked through a lot of the principles and research that we use to guide ourselves as we reimagine touch for Windows 8. I want to spend a little bit of time talking about a couple of points from that talk, as well as touching on a brief overview of some of the options that you have available for building great touch apps. Now, one key aspect of touch is scrolling and zooming. And this is something that's very common in applications. You'll see this when just trying to allow your users to get to more content, when they're moving through items in a list, or if they're zooming to get in more detail on a photo. Nearly every app is going to encounter this. Now, there's some situations where you're going to need to know more information about what the user is actually doing to be able to build a great experience. And for that, we'll show you how to use the pointer events and the gesture events to get access to that information. Finally, we'll spend a little bit of time talking about how do you put all these pieces together. After the talk, Reed and I will stick around for a little bit to answer any questions that you might have. All right, so when we first started thinking about touch, we started thinking about how users were currently using the system. And as we did that, it started to change the way that we thought about how we wanted users to use the system. But it didn't stop there. It also changed the way that we thought about how we want to expose that information up through the platform in order to make it easier for you guys to build great touch apps. Now, if you did get a chance to attend that talk, you may have seen a slide like this. That talk goes ahead and walks through all of these points in much more detail. Today, I just want to run you through one kind of series of studies that we did. So one thing we did is we just started observing how users used their devices. And when we did that, we noticed that there were two ways that were very common for them to actually use that device. One way is where they actually held the device, rested it on something, and then used the other hand to interact with the whole screen. The other common thing that we saw is where they actually held the device in two hands. And when they did this, we saw that they could only use their thumbs. Now, we found that kind of interesting, and we wanted to dig in, go a little deeper. So what we did, and you probably saw this in the keynote, is we went ahead and painted their thumbs. And we actually had them draw where it was both easy to access and where it was more difficult. And we did this with a bunch of users. And eventually what we came up with was a heat map that looked something like this. And what this shows is something kind of interesting. While your user's focus is going to be on the center of the screen, one of the easiest places for them to interact is actually on the edges of the screen. So this is a lesson that we learned and that we've used to be able to help kind of guide some of our designs, and it may be something that's useful to you as you think about how to create your apps. Now, we did a bunch of studies like this, and we continued to kind of think and iterate and try to figure things out. And eventually, we started to land and converge on a touch language. Now, what exactly is a touch language? It's two things. It's the set of gestures that a user is going to use to interact with the system, and it's also the meaning behind those gestures. Now, in Windows 8, there are 7 gestures that allow users to do everything. And from a platform perspective, we wanted to make sure that it was very easy for you to incorporate this language into your apps and get the interesting information about those gestures. So for example, when a user rotates their hand on the screen, we don't want you to have to do a bunch of math to try to figure out what's the angle that their fingers have rotated through. Instead, we'll go ahead and tell you that a gesture is occurring and what that angle that they've moved through. So how do you go from this language to actually building apps? And really, there's a bunch of options that you can use. But when you start to think about how do you want to approach this, you really want to start at the top of this list. Now, if you use things like the app templates and the controls, they've already done a lot of the heavy lifting for you to actually build on the functionality of the lower levels of the stack. The other thing that they do is they codify the Windows 8 best practices. What this means for you is that as you're building your apps, if you start by using these things, you'll be able to build great experiences very quickly. This will leave you with more time to be able to focus on what makes your app different and your app great. Now, at the other end of the spectrum are the things like the WinRT gesture recognizers. And what these do is these will allow you to have a lot more flexibility. So for example, maybe you want to allow your users to be able to move multiple elements on the screen and maybe rotate them at the same time. This is a perfect case where you'd want to go ahead and use one of these gesture recognizers. Now, the scrolling and zooming views, the gesture events, and the pointer events is where we're going to spend the rest of our time today. If you're interested in any of these other options, there will be links at the end of this deck to go ahead and point you to other sessions and other material. Scrolling and zooming views. This is a quintessential experience when it comes to touch. One of the first things your users are going to do is they're going to put their finger down on the screen, and they're going to slide it. And based off of how well your app responds, they're going to start to form opinions about how good or how great your app is. Now, when we started to think about these experiences, we came to realize there's a lot of details and nuances that need to be gotten right in order to have a great experience. So when we started out just thinking about kind of the interaction in general. And when we did that, we thought about just sliding the finger on the screen and stretching the fingers to pinch. And when we did that, we wanted to make sure our users were able to go ahead and interact directly with the content rather than having to work with some abstraction like another control. The other thing we thought about is, well, what happens when the user's finger leaves the screen? Now, in this case, we want to make sure that there was a nice inertia effect. And what that does is it has to serve two goals. It needs to allow users to be able to pan to kind of faraway locations while not feeling like it's slippery and like they're trying to pan on ice. We want to make sure it was predictable. Now, after that, we started to think a little bit more about kind of the content in general. So for that, we started to think, what about the edges? How do users actually know when they get to the end of the content? And for that, we have things like the bounce effect. Now, another thing around the content is, what about the key locations? Well, we added a feature called snap points. And snap points makes it easy for users to get to those key locations. And we'll talk a little bit more about those in a little bit. And then finally, we thought about, what can the content actually be made out of? What happens if you put a button in the content? Or what happens if you put another scroller in the content? What's supposed to happen? Which thing is actually supposed to respond? Is it the control, or is it supposed to be scrolling? Now, luckily, well, not luckily, the platform has already built in support for all of these questions. So all you have to do is use the built-in support and the built-in controls, and you actually get all of these experiences for free. So let's go ahead and take a look at how this stuff actually works in today's build. All right, so what I'm going to go into here is our news app. And what you'll see here is a list view. And what it allows you to do is to scroll side to side. And when I put my finger down, you'll notice as I move it left and right that the content just follows along. It's exactly what you'd expect. Now, if I let go as it's moving, you get that nice inertia effect. When I get to the beginning of the list, you'll notice that now as my finger moves, it goes ahead and starts slipping. And that's that indication to the user that they're at the beginning of the content. Now let's go show a couple examples of the controls. So there's really two types of controls. There's one type of control where the primary way that you interact with it is things like tap. And in that case, what you want to do is we actually want to allow the scrolling and zooming to win. So you'll see when we press down on it, it goes into its press state. But once I start moving, it drops back into its rest state, it does not fire, and scrolling occurs. In contrast, there's things like the slider control. And this, the primary way that you interact with it is you want to grab that thumb and you want to move it. And what you'll see is exactly what you expect. When I touch down on it, that control goes ahead and consumes the input, and no scrolling occurs. And then finally, I want to show you one other thing, which is the start screen. Now, this is not an app built with HTML. But what you'll see here is you get that same follow the finger, the inertia effect, and the bounce effect. And I really want to drive that point home. This is the same experiences. So use the built-in scrolling and zooming views to get the look and feel of the start screen and other Metro-style interfaces. Now, what we've done is under the covers, we've actually built a system component. And that system component is responsible for powering scrolling and zooming in all of the UI frameworks that are used to make Metro-style interfaces. And what that means for you is that if you use the scrolling and zooming support that's built in, you'll get the same experiences. And your users, when they transition from one app and into yours, or from the system and into yours, they'll get a seamless transition, and it'll just feel comfortable and natural. So we've talked a little bit about what the platform provides you, but how do you actually use this stuff? So when we started to design the APIs, we had one key goal in mind, and that was that we wanted to make it familiar and easy to use. So wherever possible, we've gone ahead and we've actually used the existing properties to be able to allow you to control behaviors. Now, for the new things that we've added and the properties that don't exist, we've gone ahead and we've wanted to make sure we followed that same model. And that model really is straightforward. It's that CSS properties are there to allow you to control the behavior. You have the DOM attributes, which allow you to inquire about the state of the system, like what the scroll position is or what the zoom level is. And then there's a set of DOM events that fire to let you know when something's happened. But rather than just talking about stuff, why don't we actually build something? So let's build a simple drawing app. And the way we're going to keep this simple is we're only going to let our users draw a couple of basic shapes. But we don't want to do that kind of boring blank canvas approach. So let's do a little bit of a twist. We'll go ahead and we'll let our users draw on top of a photo, and we're going to let them then pan and zoom around in that photo. So let's go ahead and start coding. All right, so I have Visual Studio up here, and I'm going to go ahead and start a new project. And I'm going to go ahead and select the blank application for the template. And I'm going to name it. Great. Now, the first thing that we need to do is we need to have some photos that we can actually put in as our background. So let's go ahead and add those. And we'll go down to our library, to our pictures, and we'll add these three. Great. So now that we've got those, let's go ahead and add a little bit of markup. So what I've dropped in here is actually 3 elements. And the first element here I want to walk you through is the image element. And what that is that's just the photo that we're going to let the users eventually draw over. The other element here is an SVG element. Now this element was what we're going to use to host all of those objects that we let our users draw. And then finally what we have is we've wrapped that inside of a div. And we put a class on this of workspace. This is the thing that we're going to actually make pan and zoom. And that way, as the image and the SVG elements move, they're going to move together. So now let's go over to our style sheet. All right, so we'll erase the default selectors here. And the first thing we want to do is we're going to go ahead and make the workspace pan and zoom. So we've done that by setting overflow to auto, and then we've set MS Content zooming to zoom. The next thing that we've done here is we've set the position to relative and the z-index to 1. And what that's going to do is it's going to create a full stacking context for us to be able to put that SVG element where we want on top of that photo. And finally here, we've gone ahead and set the height and the width to 100% so that the content fills the screen. So the next thing we need to do is we need to just make that image fill the workspace. So we go ahead and do that by setting the height and the width. And then finally, we're going to position the SVG element. And now what you'll see here is we've done that by setting the position to absolute and the z-index to 2. And now that SVG is on top of the image. So let's go ahead and run this and see what we've got. All right, so what we have here is our photo. And you'll notice now that I can pinch, and I can go ahead and zoom in. And then once I do that, I can actually pan around in the content. All right, so that's great, but it's kind of just the start, right? So let's talk about a couple of other features that we can do. So there's 2 features that will be useful in making this experience more engaging. That first one is snap points. Now, I mentioned before, snap points are used to make it easier for you to get, or for your users to get to key locations in their content. There's really 2 types of snap points. There's proximity snap points, and what these do is they're designed to fade into the background and make it feel like your user's just great at panning. So for example, you might use this on a piece, or on a heading in a piece of text. Then if your user is just moving very slowly through, the snap points will stay out of the way. But if they're moving very quickly and they happen to land close to one of these snap points, we'll just adjust that inertia curve so it snaps and you get a nice clean view with that heading. Now, the other type is mandatory snap points. And what that does is it gives you as a developer a guarantee when that content comes to a rest that it's going to land directly on that snap point. So in our case, we can use those to be able to create nice views of separate workspaces. Now, before we can actually do that, we need to rely on one other feature in the platform, and that's nested scrolling. So what we want to do in our app is we actually want to allow our users to pan and zoom inside of a workspace and then pan between the different workspaces. And the thing that we're going to do is we're going to just let the platform figure out what's the right one to move. So let's go ahead and code this piece up and see what we get. All right. So the first thing we need to do is we need to go back to our markup, and we're going to add a couple more workspaces. All right. And what you'll see here is exactly the same code we wrote in the first step. The only thing that we've changed here is the ID of the SVG element and what the image is actually pointing at. Next, we need to go ahead and we need to put this inside of something that will scroll horizontally. So the way we'll do that, we'll come up here. We'll put this inside of a div. And we'll go ahead and close this at the bottom. Great. So now we've got that structure to what we want. So now let's go over to the CSS and actually make this scroll horizontally. So what you'll see here is I've gone ahead and set overflow auto to enable scrolling. And then the next thing I've done is I've set the display to MS box. And what this is a flex box. And it does a bunch of stuff around layout. But by default, what it does is it changes the way that content is overflowed. So now, rather than overflowing vertically, it'll overflow horizontally. And the last thing I've done is I've set the height and width to 100%. So now we've got it so that we have a workspace, and we can pan and zoom in that, and now we can pan between the workspaces. Now we just need to add our snap points. So let's do that. And you'll see here, with just 2 lines of CSS, we can add those snap points. The first thing that we do is we set the snap type to mandatory, and then we tell the system where do we want those snap points. And the way that we're doing this is through the snap interval. And what all that does is it sets the first snap point at 0, and then sets one at the width of the scroller, and repeats. And since our workspace is the same size as our scroller, we get a snap point on every workspace. So let's go ahead and run this and see what we've got. All right, so now what you'll see is I can still zoom and pan, but now I can also move over to another workspace. And I have this nice effect here. And I can zoom in on these. I can go back. Now, I want to make one other point here, which is the scrolling and zooming views let you harness the power of Windows 8 to build highly responsive experiences. Now, that system component that I mentioned earlier, it has one other key purpose. And that purpose is to build a pipeline directly from the input stack to the output stack. And what that means is that if you're building an app and it's busy on the UI, or the UI thread is busy doing something else, say it's doing layout or is running some of your JavaScript, by using the built-in support in that pipeline, you can actually get highly responsive experiences. It'll actually still respond. Now, I've thrown a bunch of points at you, but the one thing I want you to remember from this is use the built-in scrolling and zooming support. It will let you get the look and feel of the Metro-style interfaces, and it'll let you get stick-to-the-finger performance. And with that, let me hand it off to Reed so that he can walk you through the next phase of the app.
Thanks, Nick. All right, let's talk about Pointer. And let's start with the demo, actually. We're going to flash forward to our completed demo. This is going to be kind of like a cooking show. You know, we're going to stick the cake in the oven and pull a baked one out. So we have our completed app here, and we're going to show a couple features of what we're going to add next. So we've got the workspaces that Nick showed. We can pan and zoom those. But we're going to also add an app bar. We want to make this.
Update the.
Oh, I'm sorry. Ta-da. OK. So app, we can pan and zoom back and forth like Nick showed, but we're also going to add an app bar. Sorry, I'm in the wrong app. Let's actually go to the final one. OK, app bar. We said this was a drawing app, so we want to be able to add rectangles and ellipses. The way this is going to work is we're going to take pointer events, and we're going to use those to add some SVG elements. So I can do things like draw rectangles and ellipses here. We can go over to another workspace and draw on top of these images as well, and the panning and zooming behaviors still work as expected. So now it's starting to feel more like a drawing app. So the C++ folks in the audience are probably scratching their head and saying, I know what a pointer is, but I don't think he's talking about the same thing I am. In Windows 8 and all of our platforms, we've introduced this concept of a pointer. Pointer really is the unified set of input for touch, pen, and mouse. It's one consistent, coherent API that lets you get at all of that data. The goal here was to simplify the developer's life, your lives. We have a design principle for our platform, code for touch and get mouse and pen for free. It's sort of a mouthful, but the whole idea behind that is simplicity. In a lot of UI frameworks today, if you were going to make something simple like a button, you'd add some mouse support. And if you wanted to make it work with touch, you'd write some new code, and that new code would probably look a lot like the old code that you just wrote. And maybe you thought about pen, maybe you didn't think about pen, but you probably want your button to work with a pen. If somebody taps on it, it should fire. So you'd have to add some extra code for pen. Pointer lets you write one set of code and have it work for all of these inputs. Win 8 is a touch-first OS. We want you to design with touch in mind. We want you to code with touch in mind. So Pointer lets you write one bit of code and then get a default experience for all of those inputs. You don't have to treat all input the same, however. If you want, you can make distinctions based on the type of input or other properties of the input. There's a talk tomorrow about ink in the platform, and they build an inking app. And the inking app's a really great example of an app where it's natural to distinguish based on the type of input what happens. When you use the pen, they're able to ink in the app, and when you use touch, you can select the ink, move it around, you can get reco results on the ink. So that's a great place where it may make sense to distinguish the different inputs. The pointer events are also very similar to the mouse events. So if you're familiar with programming in JavaScript and using mouse events, then using the pointer events will really be pretty straightforward for you. So what are the basic pointer events? Pointer down, pointer move, pointer up. It looks a lot like the mouse model. The events themselves actually internally derive from the same event class, so you get all the same properties. If you are looking for things like the source element or the target element, they're there. Additionally, we follow the same event propagation path, so there's the capture and the bubble phase. You can set up listeners for these. There are also pointer properties on these events, things like the position of a touch or a pen or a mouse. You can get them in whatever coordinate space you want, client, screen, page, etc. There's also the type of the pointer. Is it touch, mouse, pen? If I put 5 fingers on the screen, the way we distinguish these is with contact IDs. Each of them has a separate ID, and so you can track those separate contacts and do something with them. There's also some input-specific properties. There's things like the contact geometry around a touch. So we have a little bounding box that the system reports for us that lets you make interesting decisions. Targeting uses this under the covers, for example. For pen, there's things like pressure and tilt and pen properties along those lines. And then all of the pointing inputs, but probably most useful for mouse, there's things like button state. So you can track if a right mouse button's down, a middle mouse, that sort of thing. There's some other events as well. If you're familiar with on mouse over and on mouse out, the same thing happens for pointer. So I put a finger down and drag across an element. When I enter the element, I'll get a pointer over event. When I leave the element, I get pointer out. MS Pointer Hover is a lot like MS Pointer Move, but for hovering contacts. So if I have a mouse and no buttons are down, we'll be generating MS Pointer Hover events. If I've got my pen and I'm hovering above the screen, you get hover events. MS Pointer Cancel is for when your input goes away for some reason. Typical examples are things like screen rotation or desktop switches, palm rejection, surprise removal of a device. There's typically 2 things developers do in response to a cancel. One is just treat it like an up. Do whatever you're going to do when the contact went up. The other option is for something like our drawing app, we might want to undo the rectangle or ellipse we were drawing. If I rotate my screen, I probably don't want to drop whatever the rectangle was at that point. And instead, I could receive the pointer cancel and remove the rectangle. So undo whatever interaction I was in the middle of. OK, so let's get back to the code. And let's actually add our pointer code to our app. OK, perfect. So first order of business is we want our app bar. We want to be able to add those rectangle and ellipse buttons. So we'll add some HTML for the app bar. This is pretty straightforward. If you go look at any of the samples that use an app bar, it looks like this. We've got a div with ID app bar and the data win control style. A couple buttons in it for our rectangle button and our ellipse button. We also need to add some includes here to get all the WinJS goodies. And in our JavaScript file, when our window's activated, we need to make sure to tell WinJS to look through all the HTML, find app bars, initialize all those, and when they're done, we're going to call onload on our document. So let's create a new JS file, and we will add some handlers for onload. Whatever, we'll just call it script.js. OK, there we go. So a couple globals, and let's add the handlers here for the app bar. So we've got some click handlers. When somebody clicks on our rectangle button or our ellipse button, all we're going to do is keep track of the fact that we're either drawing a rectangle or drawing an ellipse. And the things that we're going to draw, we want to add some styles to those. So let's put some CSS in here for our SVG elements. So anything that's under our root SVG node, which is just going to be rectangles and ellipses, we're going to set the stroke color, the stroke width, and some fill information so that it looks like those sort of mostly transparent shapes you were seeing before. Next, let's add onload. So onload gets called after we've finished adding the app bar to the app. And we're going to do a couple things here. First of all, we're going to find our scroller, and we're going to add an event listener for scroll. When somebody scrolls, we want to keep track of what our current workspace is. So internally, we'll update the current workspace global up at the top and current drawing space, so we know whether we're in the sort of left, middle, or right one. We also add some listeners here for the pointer events. So we walk through each of our workspaces, and we add listeners for pointer down, pointer move, pointer up. The MS manipulation state change that we're listening for on the scroller and the workspaces is for if you start panning or zooming, we're going to cancel any drawing that we were doing there. So we'll just call reset interactions, and all that does is clear our state. And we set up click handlers on the rectangle and ellipse button. So at this point, our app bar should be pretty good. Let's start adding some utilities and the handlers for our pointer events. OK, so in our utilities file, I just coughed a lot of JScript in there. But basically, it's some helpers for handling matrices, doing matrix multiplication, a point class, some basic utilities that we'll use throughout this. And back here, let's add our pointer events. So let's walk through these somewhat slowly. So on pointer down, the first thing we want to do is remember where the person tapped with their finger or the pen or the mouse. And then if we're drawing something, we're going to create a new SVG element. Either it's a rect or an ellipse. We're going to parent it to the appropriate SVG root, so current drawing space, and then just append it as a child. And then we're going to set up some properties on it. For the rectangle, we're going to set the X and Y for the upper left-hand corner and give it no width. And for the ellipse, we're going to set the center to where the person went down, and it has no X or Y radius. In onPointer move, we're going to track the current position of the pointer. So as it moves around, we will update the height and width of the rect or the X and Y radiuses of the ellipse. The only tricky thing here is you can't have a negative height and width in SVG for a rect. So if it does go negative, like if you go down somewhere and then sort of drag your finger around it in a circle, we will flip which point is which here, which is what's going on in these last lines here. Pointer up's pretty straightforward. We've been tracking the position of the pointer and updating the SVG as we go. So all we need to do is finish drawing, clear out our SVG element, and we should be good. So let me make sure we actually load these script files here. And let's run it and see what we have. OK, so we can still pan between the workspaces. We can zoom. We've got our app bar. And when I tap on rectangle and drag, oh, hey, look, we get panning. Now, Nick will talk about how to fix this next. But for the short term, what we're going to do is we're just going to comment out the styles that gave us panning and zooming in the first place. And we'll see if that fixes our issue. So we comment out the scroller, which was giving us the horizontal panning. And we comment out the workspace, which was giving us the zoom and the pan effects inside the individual workspaces. And now you can see we can no longer go back and forth between the workspaces, but we can draw our SVG elements on the screen. So we've gotten the drawing portion of this working. So capture is another concept that Pointer supports. If you're familiar with mouse, you probably understand capture. The basic idea here is you've got some input and you want to direct it to a different element. You saw a good example of capture in Nick's very first demo. When he was working with the slider control, he put his finger down on the slider thumb, but then he could drag off it and still move the slider thumb. And the thumb tracked his finger even after he dragged off it. The way that works under the covers is we set capture to the thumb when you go down on it. And then even if you drag off, the input is still directed to the thumb, and it can update its position. We will also use capture in the gesture section when we add gestures to our sample, but we're not there yet. So there's a couple APIs for capture. You can set capture and you can release capture. You can also query capture with msget pointer capture. And there's events. If you change capture, if there was an event that gained capture, it has an event. And if an element had capture and loses it, lost pointer capture is generated. There's also some other goodies. Get pointer list lets you retrieve the set of all pointers that are currently active and in detection by the system. There's a couple scenarios you might use this. One is maybe you have a button, but you don't want that button to take effect if somebody's doing something else in your app. Like maybe in the inking app, I don't want to be able to change the color of my ink while I'm actively inking. I can call get pointer list when somebody taps on one of the buttons to change the color of the ink and see if there are other pointers down in my inking surface. Another example is maybe you have some element that's very greedy, and if any fingers are in it, you want to capture all the input to it. You could use get pointer list to determine when a finger comes down in there, if there's other elements you need to capture to it. Disable mouse events is interesting. When you use a pointer device, touch, pen, mouse, and interact with your HTML app, we generate pointer events, and they flow through the DOM as you'd expect. But we also need to generate mouse events. And then whatever the primary pointer was, we'll also generate a stream of mouse events for that one. That's the one that would drive the mouse. In part, this is so that legacy web pages continue to work as expected. Pointers available both on web pages and in Metro-style apps. So you can use disable mouse events if you don't want that mouse promotion. Maybe you have some legacy mouse behavior, but if pointer events come in, you'll handle those and then disable the mouse events. Like I was saying, pointers available in web pages as well. If you want to check whether pointers available on whatever client you're running on, you can use this method off navigator, navigator.ms pointer enabled. That lets you know whether pointers available on that system or not. All right. Nick's going to show us how to fix panning and zooming.
That's right. Thanks, Reed. So when Reed hit that problem, he went ahead and just commented out the code that did scrolling and zooming. And the reason he did that is there's one key concept to keep in mind as you're putting this stuff together. And that's the DOM pointer and gesture events cannot be used inside of an active scrolling and zooming region. Now, what does that really mean? All that really means is that your app needs to make a decision when the user puts their finger on the screen, whether they want scrolling to occur or if they want to receive those events. Now, the reason we did this is we wanted to make sure it was very easy to build highly responsive apps. So how do we actually indicate to the system we want these events? Well, there's really two approaches. If your content's never going to pan or zoom, just set the styles appropriately. Set overflow to hidden, set MS content zooming to none. This will indicate that to the system that there's no panning or zooming, and therefore it'll be smarter about how it routes the pointers through the system. Now, if you're like our app and you actually need to decide at runtime, you can call prevent manipulation. And you call that on the MS pointer down event or on the MS gesture init event. After you've done that, if your app needs to change its mind, you can actually trigger scrolling and zooming to occur again. And you do that with another use of the MS set pointer capture API that Reed had already introduced. Now, let me show you an example of our list view control. This is something that actually goes ahead and does both of these things. All right, so what you're looking at here is the News app. And there's two things that can happen when the user puts their finger on the screen and slides it. The first is that scrolling occurs, and the content just follows along. But you'll notice that when I move my finger up and down, the item responds. And the way this works is the list view is calling prevent manipulation as soon as that first pointer down message comes. So in the case where I'm moving my finger up and down, it goes ahead and just continues to receive those events. Now, when I move my finger left and right, what it does is it goes ahead and listens to a couple of events, determines that I'm actually trying to scroll, and then goes ahead and calls MS set pointer capture to go ahead and trigger that. All right, so now let's go back to our code and let's actually fix up our app. All right, here. So the first thing we're going to do is we're going to bring back all the code that Reed commented out. Sorry, Reed.
All my hard work.
All right, so now that we've done that, we're going to go over to our pointer down handler. All right, and here we only want to actually prevent manipulation when we're actually drawing. So we'll go ahead and inside of this if clause, we'll go ahead and add this here.
Cursor was in the wrong place.
We are going to type this. Oh, and now I'm live typing. Manipulation. And we'll copy that. And we'll go ahead and paste that in when we're drawing the ellipse as well. All right, and with those two lines, we've got the panning and zooming back to working. We can swipe up for the app bar, and we can go ahead and draw our shapes. And with that, let me hand it back to Reed to go ahead and take the last stage of our app.
OK. So drawing these rects and ellipses is fun, but we can do more than that. Let's do a quick demo here. So again, we're going to flash forward to the final app. And wouldn't it be nice if after we drew these things, we could interact with them? You know, maybe I didn't really want a rectangle, I wanted a diamond, or I want to be able to move these things around. We can, oops, well, demo quirk, we're not actually fixing up the Z order in this, and when we get to the code, I'll explain why that happened. But so the idea here is that not only can you draw these SVG elements, but we can interact with them now too. You know, maybe I'm building a game or something like that, and I want to have some paddles and move them around if I'm building Pong. Manipulations are a great way to do that. Okay. So not only do you get raw input through the pointer events in the DOM, but you can get gesture events as well. And the really nice thing about gesture events is all you have to do is add your event listener for one of our gestures, something like manipulations, like we were just showing, or tap, and we will plug in gesture detection behind the scenes for you and generate those events when the pointer data that comes to your element is a gesture of those sorts. It's really easy to add gesture detection to your HTML apps. One of the other things here is our principle about code for touch and get mouse and pen for free applies not just to pointer data, but also to gesture events. The gestures that are fired can be fired from any of the inputs. So for example, you can tap with your finger, with a pen, with mouse. You can manipulate as well. Something like using a pen is very similar from the platform's perspective as using a single finger. These gestures fall into two categories as well. They're static gestures and dynamic gestures. Static gestures are one-shot, one-off kinds of gestures, things like a tap. Dynamic gestures are ones that have a start and an end and some set of state that updates along the way. So if I put 5 fingers down on my screen and sort of moved like this, we'd get a gesture start. We'd get a series of updates as they move and rotate and whatnot. And then when I lift my fingers, we get a gesture end. So static gestures. Some of the more commonly used ones are gesture tap. If my hand is a button, a tap's pretty straightforward. Your finger comes down and lifts. Hold is a little more complicated. We have a couple states here. Hold is a timed gesture. So if I put my finger down and don't move and hold for a while, when we've crossed that time threshold, you'll get an MS gesture, a hold start. Now, one of two things can happen at that point. I can either lift my finger and successfully complete the hold, and we'll get an MS gesture hold end, or I could drag away, and we'll get a hold cancel. If you were also listening for manipulations, we would have transitioned to manipulations, and you would start getting that kind of data as well. So what are manipulations? Manipulations are any combination of moving things, resizing them, rotating them. For those of you who really like linear algebra, you can think of it as an affine 2D transform. There's a series of manipulation events as well. So MS gesture init is your chance to decide whether or not you want this to be a gesture. You typically do things like call prevent manipulation if you do want it to be a gesture, and that's what we'll do in our app. But you might hit test the gesture and decide, is it on some content that should be manipulable? Is it not? And decide whether yes or no it should be a gesture. If it is a gesture, then the next thing you'll get is MS gesture start. This is the beginning of that interaction. If I put my 5 fingers down, we'll get a notification that a manipulation is starting and know about the point. As I move my fingers around, we get MS gesture change events. They will update us with the position and how the manipulation is changing over time. And then if at the end of that interaction I let go and I was moving with sufficient velocity, we'll trigger inertia. So you get an inertia start message, and then you'll get a series of gesture change events indicating that the manipulation is ongoing and inertia is driving it. At the very end, when it has come to a stop and all my fingers are off, we get a gesture end. So these events contain many of the properties you'd expect. There's things like the position. For when you're using multiple fingers, the position is the center of that manipulation. You can think about it as the center of gravity, the pivot point of the manipulation. You also get the cumulative translation, rotation, and scale changes, as well as velocities for all of those. So there's linear velocity for how you're moving in the XY plane. There's angular velocity for rotation and expansion velocity for changes in scale. OK, so let's add these gestures to our app and see what that code looks like. OK, first order of business is we're going to want to set capture. I told you before that we're going to use the set capture APIs. One of the subtleties here is when pointer events are delivered to you, they are delivered relative to the element that they are going to. So if I put my finger down on an SVG element, I get those points in that element's coordinate space. If I've changed that coordinate space by scaling and rotating, then my point is also now in that scaled and rotated coordinate space. That's going to make our math a little bit harder for applying the transforms from the manipulations. So to simplify things for ourselves, we're going to set capture to a parent element whose coordinate space doesn't change. Due to a quirk in the platform, remember this is a developer preview, we're going to add an anonymous div above these root SVG elements. We cannot currently capture to these SVG elements. But we'll create some divs here just to wrap these. And we're going to set capture to these divs that wrap our SVG and image elements. OK, so we've got our divs there. Now, we could capture on down if we wanted to. But the problem there is the down coordinate is going to already be in the coordinate space of the element it was delivered to. All future input will go to the parent div and be in the right coordinate space. But if we want the down to be in the right coordinate space as well, we'll capture on over. So we'll listen, we will add listeners for ms pointer over. Oops. There we go. And let's add a handler for that. And all we're going to do in the handler is figure out what our current drawing space is, so which of the SVG elements we're in, go up to its parent, which was that anonymous div, and then just set capture to it. So whatever the pointer ID was, we will take that and tell the DOM to capture that now to the parent. So whichever SVG rect or ellipse it was in, it's going to end up being delivered to the div instead, and its coordinate space isn't going to change. So let's also add some handlers, or sorry, some listeners for gestures. So here in onload, we're going to walk through those same divs that we set capture to, and we're going to add listeners for our gesture events. So gesture init, gesture start, gesture change, gesture end, and inertia start. In pointer down, there's one little bit of extra code we're going to add. We'll talk about this in a second. It will make more sense when we add our gesture handler, which is the last bit of code we need to add here. Now we could have set up this handler as a series of handlers, one for each event, but it's easier to walk through the code if you see it all sort of in sequence, and there's some shared code between them. So what do we have? We've got a couple new variables that we're going to use. One tracks the previous state of the manipulation that was applied to whatever element we're working with. We're going to use deltas here between each gesture event and apply those deltas to slowly build up the full transform on the object as we manipulate it. We also have a variable that will store that delta in, and we keep track of the prior transform. This will be one of our matrix classes that we defined in the utilities. This is the sort of full prior transform that was applied to the element. OK, so if we get a gesture, we get called an onGesture. The very first thing we want to do is check if we're drawing either a rectangle or ellipse. If you remember before when we were adding the pointer events, if you just put your finger on the screen and drag, if we're not calling something like prevent manipulation, that will zoom and pan. It also gets treated as a gesture. Because we're listening for manipulations and because you can generate a manipulation with a single finger, you'll be getting these gesture events. So if we are drawing one of these two things, then we bail out. We don't want to manipulate it while we're drawing it. Next thing we do is we do some hit testing. So this call to element from point and then checking whether we're a rect or ellipse is determining whether the person has put, is manipulating one of our SVG elements or if they're manipulating somewhere else. If they're manipulating somewhere else, again, we don't want to do anything and we're just going to bail out. OK, so if we've gotten as far as the switch statement, then we're fairly sure that the person is manipulating one of our SVG elements. And so we want to start building up the new transform that we need to apply to those elements. So in msgesture init, we call prevent manipulation. We don't want to be zooming or panning. In msgesture start, we'll ignore this inertia stuff for a second, but we set up some initial state for ourselves. The previous state for the manipulation we set up as an identity manipulation. So there is 0x translation, 0y translation. We're scaling by a factor of 1, and 0 rotation. And remember that code we added at the end of pointer down? This? All this was doing is setting our little expando property, current transform, on our SVG element to the identity matrix. So all of our SVG elements will have something set for current transform. And if we haven't manipulated them yet, it'll still be the identity matrix. So we pull that property off whatever element we're interacting with and keep track of it. We're going to need that later. All right. So msgesture change is where a lot of the work happens. The first order of business is to calculate our delta. So we have some new update from gesture detection. We know what the new cumulative translation scale and rotate values are. And we take those current cumulative values and whatever the previous value of the last manipulation was and subtract or divide to figure out the delta. So for example, we take the cumulative translation and we subtract off the translation from the previous manipulation. Same thing for y. For scale, we divide. Rotation, we subtract again. So now we have our delta. This is the set of changes that have occurred since the last time we got an MS gesture change event. We're going to build up a couple matrices here. And the easiest way to think about the transform we're going to apply is, we've got some SVG element. It's in some state. If we want to transform it, what we need to do is we need to build a translation transform that moves it back to the origin. Then we'll apply our scale and rotate changes. We'll do whatever translation occurred as part of the manipulation, and then we'll apply the inverse of that transform that got us to the origin in the first place. So those are the matrices we're building up here. T1 is that translate matrix that takes us back to the origin. S is our scale, R is our rotation. T2 is a combination of both the delta in translation plus the inverse of T1. And M is the multiplication of all of these things plus the prior state of the transform on that element. So M is our new transform that we need to apply. We set the transform property on the SVG element, and we give it our matrix, and we pull out the appropriate elements in the matrix and set them there. Now, just a little bit of bookkeeping. We'll update whatever the previous state of our manipulation was to that new cumulative value that we got from gesture detection. We'll update our previous transform as well to M, and we'll save it off on the element as well. So now everything's updated with the appropriate state for the next gesture change event. So let's say I was taking that SVG ellipse and I rotated it really fast and let go. We're going to get some inertia. We're going to get some angular velocity there. And when that happens, MS inertia start gets called. And we will note to ourselves that we're currently in inertia. And in this app, we don't want somebody to be able to throw one of our elements off screen. So we don't want any inertia. What we're going to do is in MS gesture change, we will check if, scroll a little far. We will check if we're in inertia. And if so, we'll just bail out. So we'll ignore gesture changes that are coming from inertia. And then eventually, we're going to get an MS gesture end. And we've already done all our bookkeeping in gesture change, so there's nothing new we have to do here. But if you had to do any cleanup or finalization or things along those lines, you would do them here in gesture end. So now if we run this, cross your fingers, hopefully we can manipulate our SVG elements. Oops. Ta-da. And all this stuff works with the zooming and panning that we had before. All right. Oh, so for those of you who are curious why, if we dragged one of the SVG elements over the other one, it starts moving, what's going on there, if we go back to our code, is when we do our hit testing, element from point, which we call up here in handling the gesture events, returns whatever the highest thing in the Z order is. So if you choose to manipulate one of the elements that's lower in the Z order, but drag over the other one, then our hit testing results change in the middle, and we apply the wrong transform to another element, and it typically shoots off screen. So that could be easily fixed by moving the element that you're currently manipulating to the top of the Z order. But to keep the sample simple, stayed away from that. OK, slides. So the astute listener has probably been thinking to themselves, hey, I am hearing him talk about this tap thing, but I've been building HTML pages and apps and whatnot for a while now, and I'm familiar with this click event. What's the difference between these things? Tap has this notion of a distance threshold. So if I put my finger down on a button and drag a little bit and let go, even if I completely stayed on the button, assuming it was reasonably large, I wouldn't get a tap. I would have dragged too far. It wouldn't be a tap anymore. It would be some drag gesture or manipulation. Click, however, functions differently. It's an event that's generated by controls. You can generate it with mouse, with keyboard. We also let you generate it with pointer events, or it is also generated on your behalf for pointer events. So even if you call something like disable mouse events to stop mouse promotion, you can still listen for click events generated purely off pointer if you want. But click, all that it cares about is that the down and up are on the same control. So for example, if I put my finger on a button, drag off, make a little smiley face, come back and let go, click will fire. So when do you use one versus the other? Well, you use click for button kind of controls. A great example in our app are the buttons in the app bar. So the rectangle and the ellipse button, that's a perfect place to use click. If you want to use tap, some place that you could use it in our app is maybe tapping on those SVG elements would cycle through colors. That would let you tap on them to change their color, but then you could still also drag them around and manipulate them. If you tried to use click for that, what you'd see is you could drag the element, it would move, but when you let go, because both the down and the up were still on the SVG element, you'd click and the color would cycle. So every time you manipulated your SVG elements, you'd cycle the colors. Probably not what you want. So the HTML platform provides a lot of goodness. We talked about a lot of things here. There are additional APIs that you can use to extend what's available in the HTML platform in the runtime. There are things like richer pointer data that you can get to. You can have much more flexible gesture recognition. One thing you may have noticed is we never manipulated two SVG elements in the app at the same time. The support that's built into the HTML framework only lets you have a single gesture at a time. But if you want to be able to manipulate multiple SVG elements, or maybe you have a game with paddles or things like that and multiple interactions going on at the same time, you can use the Windows runtime gesture recognizers to do that. We also have device APIs and other goodness in the runtime. And all this is stuff that you can add to your HTML apps if you want. OK, so what's the message? Hopefully everybody's excited about building HTML apps. If you are, and you should be, start with controls and templates. These really codify the Windows 8 best practices. They give you a lot of the touch language for free, our design guidelines, and they do a lot of the heavy lifting for you. So they're a great place to start. For very little effort, you get a lot. You can also add really great scrolling and zooming views using the CSS properties that Nick's talked about. If you want to get raw data and build a painting or drawing app like we showed here, or build games, or do custom gesture recognition, use the pointer events. And if you want to take advantage of the Windows 8 touch language and reuse that in your app, if you want to be able to manipulate things, use gesture events. And if you need more than that, you can go to the runtime and get the full power of the platform in addition to what's available in HTML. So you have a lot of tools at your disposal when you're building HTML apps. OK, a couple related sessions. I'll just pick out some highlights here. 162 is a great perf talk that Matthias is giving on perf and HTML apps. 503 is the XAML version of this talk. Eleanor's in the audience somewhere. He's giving that talk tomorrow. 186 is our deep dive on WinRT. That's tomorrow morning. And last but not least, 391 is a great talk on designing these kinds of apps and how the touch language and our experiences building Win8 played into that. A couple other quick resources. We have an SDK sample, panning, scrolling, and zooming, that shows the things that Nick talked about early on. Canvas Paint is a really simple, basically, recreation of MS Paint using a canvas and the pointer events. It's a good sample, pretty straightforward. Touch Events is a simple sample, but it uses both pointer events and gesture events. We, of course, have docs up on dev.windows.com. So thank you, guys. We'll be happy to take some questions here. I think the expo hall is closed, but you can also find us there tomorrow morning. And don't forget to fill out your evaluations. Thanks, and we're really looking forward to seeing the apps you guys are going to build.